All right, let's pull back the curtain on one of the most fundamental jobs of any modern operating system, process management.
Think about it. It all just works, right? It feels completely seamless. But under the surface, your computer is performing this incredible high-speed juggling act. And today, we're going to uncover the secret behind that magic.
Okay, so let's get right into the heart of it. We're going to start with the fundamental trick of the trade, how a single CPU core can create this powerful illusion of doing dozens of things all at once.
So here's the secret. Your CPU isn't actually running your browser and your music at the exact same millisecond. Nope. Instead, the operating system is switching the CPU's focus between different tasks like thousands of times a second. It happens so fast that it creates this perfect illusion of everything running in parallel. And the star of this whole show is something called a process.
So, what is a process, really? Well, you can think of it as the main character in our story. It's the fundamental thing that the operating system has to manage in its grand performance. The textbook definition is simple. A process is a program in execution. It's not just the app icon sitting on your desktop. That's just code. A process is that code brought to life, an active, living entity that's currently running and doing something.
And you can think of each process as having its own little self-contained universe. It's got everything it needs to do its job: the actual program code, a record of its current activity, its own temporary scratchpad of memory, and all of its data. Now, this isn't just some abstract concept. Under the hood, the OS is doing some serious bookkeeping. In an operating system like Linux, every single process is tracked with a data structure just like this one. It's basically an ID card for the process, holding its current status, which process created it, what files it's using, a map of its memory, literally everything all in one neat package.
So let's follow the story. From the exact moment you launch an application, its process begins this fascinating life of constant change, shifting from one state to another, all under the OS's watchful eye.
You know, a common misconception is that a process is always, well, processing, that it's always running, but actually, it spends most of its time waiting, just waiting for its turn on the CPU, or waiting for something else to happen.
It really boils down to three main states. A process is either actively using the CPU, that's the running state, or it's paused, waiting for something, maybe a file to download, that's the waiting state. Or, and this is where it spends a lot of its time, it's sitting in line, totally ready to go, in the ready state.
And the OS is an absolutely brilliant organizer. It keeps all those ready processes in a tidy line called the ready queue. And for any process in the waiting state, it has specific lines, or device queues, for everything from your hard drive to your network card. Everybody waits their turn. Okay, so you've got this big line of processes in the ready queue, all chomping at the bit. How does the OS decide which one gets the CPU next? Well, that is the critical job of the CPU scheduler, the ultimate juggler that keeps this whole act going.
Now check this out, because this shows just how much the scheduling strategy matters. This is a super simple first-come, first-served approach. If a long task shows up first, followed by two really short ones, the average wait time for everyone is 17 milliseconds. But if you just change the order and let those two short jobs go first, the average waiting time plummets to just 3 milliseconds. Now that might not sound like a lot, but multiply that difference across thousands of operations a second, and it's what makes a system feel snappy and instant instead of sluggish and slow. It's a huge deal.
And that's why modern operating systems use way smarter algorithms than just first come, first served. Their whole goal is to keep that CPU busy while making sure no process has to wait too long. It's all about keeping your computer feeling fast and responsive.
So we've seen what a process is, we've seen how it gets scheduled, but how does the OS actually do the swap? How does it pull one process off the CPU and put a new one on? This right here, this is the secret sauce behind the multitasking illusion. It's called a context switch. And it's the physical act of changing which process gets to use the CPU's super-fast onboard memory and all its other resources at any given moment. Here's the play-by-play. It happens in 3 steps. First, the OS saves a perfect snapshot of whatever the current process is doing into its little ID card, its process control block, or PCB. Second, it pulls up the ID card for the new process and loads its save snapshot. And finally, the new process just picks up and resumes running exactly where it left off. And this whole thing happens thousands of times a second, completely invisible to us. So this whole thing, this incredibly intricate dance of creating, scheduling, and switching between all these processes. This is the absolute bedrock of modern computing as we know it.
And, understanding these concepts, processes, scheduling, context switching, it's not just for computer science class. It really demystifies how our computers can juggle so much at once. It's the foundation that makes everything possible, from the simplest app on your phone to the most complex cloud servers that run our entire digital world.
But here's a final thought. This entire system was originally designed back when computers had just one single CPU. So how does this whole complex dance change when your phone or your laptop has 4 or 8 or even dozens of cores all working at once? Well, that opens up a whole new level of complexity. And that's thought for next time. Thanks for joining us.